Welcome everyone. In this video we're going to do a 14.7 problem. This is from spring 2017. There it goes, finally snapped into place. And we're going to be talking about absolute minimums and absolute maximums. And so this is a two-part question. You can see it takes up the entire page. Part A is find the critical points of F, classify them as local mins, maxes, and saddle points. And then part B, we want to find absolute mins and maxes on the boundary. And this is all in caps, right? Boundary of D, so not necessarily interior, but just the boundary. All right, so let's go ahead and get started here. We're going to do part A. We're going to find and classify some critical points. So I'm going to calculate out f sub x, and I'm going to calculate out f sub y. This will help me locate our critical points. So f sub x, this is going to be x squared minus y. And then f sub y, it looks like I'm going to have negative x plus, y minus 2. All right, so it doesn't look like these are either, ever undefined. So let's think about what would it take for them to be equal to 0. Well, in the first case, it would mean that we would have y is equal to x squared. And in the second case, it looks like we would have y is equal to x plus 2. Once we kind of switch that around, that's what it would take for these both to be equal to 0. And so you can go ahead and kind of sketch this, or you could set them equal to each other. Maybe I'll use the substitution method. So I'll set them equal. I'd have x squared is equal to x plus 2. So this would give me x squared minus x minus 2 is equal to 0. And so if I go ahead and factor that, I think I get x, minus 2 and x plus 1. And so that means at x is equal to negative 1 and at x is equal to 2, this is where they intersect. What are the corresponding y values? Well, I can go ahead and plug them into either one of these. So for instance, I plug them into the first one. And so if I plug in negative 1 into the first one, this would give me negative 1 comma, and negative 1 squared would be 1. And if I was to plug in 2, right, 2 squared is going to be 4. And you can double check. If I was to plug these in down here, you would get the same result. So there are our critical points. Now we have to actually classify these things. So to classify them, that's where we move on. We need to calculate out this D, the determinant of the Hessian matrix, all that good stuff. So let's go ahead. I'm going to calculate out f sub xx, f sub xy, and f sub yy. And that's going to help me calculate out D. So if I take a second derivative with respect to x, now notice I'm looking up here. I would get 2x. If I take a derivative instead with respect to y, I would get out negative 1. And now if I look at my second one right here, my f sub y, and I take a derivative with respect to y, I would get 1. So therefore my d, in this case, f sub xx times f sub yy, that's going to be 2x minus f sub xy squared. So that's going to be negative 1 squared, that's going to be 1. All right, so now at the point negative 1 comma 1, we have that D is equal to, and again I'm plugging in negative 1 everywhere I see an X, 1 everywhere I see a Y, so that's going to be negative 3. That's less than 0. So negative 1, 1 is a saddle point. How about at our other point? So at our point 2, 4. In this case, D, again, I'm plugging in 2 everywhere I see an X, 4 everywhere I see a Y. So that's going to be 4 minus 1, that's going to be positive 3. That's greater than 0. So therefore, we're in Calc 1 world. I need to look at f sub xx. F sub xx, again, I'm plugging in 2 everywhere I see an X. So that's going to be 2 times 2, that's equal to 4. That's greater than 0. So therefore, given this information, we have, 2, 4 is a local, again, this is concave up, so that's going to be a minimum, kind of opposite of what you would maybe normally expect. So there we go, we have found and we have classified our critical points. All right, now B, we want to find the absolute max and minimum, not for the interior, right? We're just interested in the boundary. So we're going to go ahead and split this up. Right, the boundary consists of 4 pieces. It looks like we have a left-hand side, we have a top, we have a right-hand side, and we have a bottom. So I'm going to consider each one of these pieces and figure out where are the maximum and minimums for each one of these, and then that'll tell me what the maximum and minimum is on the overall thing. So okay, let's go ahead and start off with maybe the bottom. This is a nice one to start off with. So on the bottom, that's this one down here. This is part of a line segment, a nice horizontal line segment. Well, horizontal line segments have equations like y equals. So in this case, they have height 0, so it's y equals 0. X is ranging between 0 and 3. So again, y is constant down here on the bottom, but x is ranging between 0 and 3. And now we're going to go ahead and use our function. So I'm going to go ahead and calculate out maybe f of x comma 0. So 0 everywhere I see a y, again, because we're on that piece of the boundary. And so, okay, let's see, we're going to have x cubed over 3. And let's see, minus 0 plus 0 minus 0. So that's all there is to it. So I'm finding minimums and maximums for this function, again, just on the boundary. So let's go ahead and maybe take the derivative of this, f prime of x. That's going to be equal to x squared. And so this is equal to 0 when x is equal to 0. So at x equals 0, and of course, remember, we're on the line y equals 0. So x equals 0, y equals 0 is a point of interest. Right? Maybe it's a min, maybe it's a max. We also have, right, these endpoints. The endpoints are when x equals 0, y equals 0, or when x equals 3. And again, we're on the line y equals 0. So really, it looks like it's repeated itself. We have this one and we have this one. If I went ahead and map these, right, they would just be this purple point right here, 0, 0, and 3, 0. There we go. Now let's go ahead and maybe do the left-hand side. So, I was going to stick with green this entire time, so let's go ahead and use green again. So on the left-hand side, again, now we're over here. The left-hand side, this is a piece of the vertical line. Remember, vertical lines have equations like x equals. So in this case, the x value here is 0. Y is ranging between 0 and 5. And so, okay, our function, now x is equal to 0, y is ranging. So I go back to our original function. Again, maybe I'm looking right here. And I'm plugging in, everywhere I see an x, I'm plugging in a 0, and y I'm leaving as a variable here. So I'm going to have, let's see, y squared over 2 minus 2y. So if I go ahead and I take the derivative of this, I'm going to get out, let's see, it looks like just y minus 2. So what would it take for this to be equal to 0 or undefined? Well, it's never going to be undefined. So our only hope for this being 0 is when y is equal to 2. Okay, remember we're on the line x equals 0. So it's x equals 0, y equals 2. So if I go ahead and plot this point, x equals 0, y equals 2, we're right here. And now let's go ahead and also include in our endpoints. So our endpoints are when y equals 0 or when y equals 5. So y equals 0, y equals 5. Again, we're on the line x equals 0. And so it looks like, again, we already have the point 0, 0 here. That one was already included. But the new one is 0, 5. So up here. Okay, so there's two of them. Now let's go ahead and do maybe the top. So on the top, this is when y is equal to 5. And again, x is ranging between 0 and 3. So in this case, we have f of x comma 5. And if we were to plug in 5 everywhere we see y into our function, we're going to get x cubed over 3 minus 5x plus 25 halves minus 10. Let's go ahead and take the derivative of this. With respect to our variable x, we're going to have x squared minus 5. And so therefore, we have a critical point when this is 0 or undefined. So that's going to be when x is equal to the positive square root of 5, or when x is equal to the negative square root of 5. Now, on our boundary here, remember, x is ranging between 0 and 3. 0 and 3. So negative square root of 5. Oops, and I wrote an x here too. That just looks like nonsense. So negative square root of 5 isn't going to be in the domain. So we exclude that one. The only one that we're left with is the positive square root of 5. Again, this is where y is equal to 5. So, okay, y is equal to 5, and x is equal to the square root of 5. Square root of 5 is around square root of 4, which is 2, but it's a little bit bigger, so maybe somewhere around here. And let me just put, just so that as I remember later, that this has the x value root 5. So something like this. Okay, and then of course we're also going to include our endpoints here. Let's go ahead back and take a quick look at that. So our endpoints, let's see, we have x is equal to 0 and x is equal to 3. Go ahead and erase that. And again, we're on the part of the line y equals 5. So y is equal to 5, y is equal to 5. All right, so that's where these other purple points come from here. And now finally we have the bottom, we have the left, we have the top. Now let's go ahead and do the right-hand side. So the right-hand side is when x is equal to 3, y is ranging between 0 and 5. So if I go ahead and I calculate out f of 3y, again, everywhere I see an x, I'm going to go ahead and put a 3. I get 9 minus 3y plus y squared over 2 minus 2y. I can go ahead and take the derivative of this with respect to y. I'm going to get y minus 5. And so, okay, this is never undefined. It's equal to 0 when y is equal to 5. Okay, so y is equal to 5. Remember, we're on the line x is equal to 3. So x equals 3, y equals 5. So this is a point that we already had. And actually, it's part of the endpoints too, right? So we would also have x equals 3, y equals 0. And the other endpoint is x equals 3, y equals 5. So again, we already kind of considered this once. All right, so these are all the points that we need to consider. We have 6 of them in total. So let's go ahead and plug these in. So this is kind of the last bit here. I'll switch to black for fun here. So our points are 0, 0. We need to figure out the value of. Let's see, 3, 0, 3, 5, 0, 5, and then kind of the ones that aren't kind of actual endpoints here, we have square root of 5, 5, and let's see, I forget what the other one is here, 0, 2. So again, we're going to go ahead and plug in these values into our function. So 0, 0, when I plug that in, I get out 0. 3, 0, when I plug that in, I get out 9. 3, 5, be a little bit careful with this one, but I get negative 7 halves. 0, 5, again, a little bit careful, but I get out 5 halves. 0, 2, this one's a little bit easier. I'm going to get out negative 2. And then root 5, comma 5. Let's be careful with this one. Again, let me go back up and let's stare at our function again. So let's see, x cubed over 3. Actually, let me maybe just write it right up here next to this thing. So again, everywhere I see an x, I'm plugging in a root 5. So this is going to be root 5 cubed over 3 minus root 5, and y was 5, so times 5, plus 25 halves minus 2 times 5, that's 10. All right, now let's simplify a little bit. So square root of 5 times square root of 5, right? If I was to just consider 2 of them, that's going to be 5. So this is going to be 5 root 5 over 3 minus 5 root 5s. And let's see, 25 halves and minus, let's go ahead and change this right here to 20 halves. Right, so, okay, 25 halves minus 20 halves, that's going to be 5 halves. So plus 5 halves. Let's go ahead and see, we have 5 root 5 in both of these, 5 root 5, and then we're going to have 1/3 minus 1 plus 5 halves. So that's going to be, let's see, 2/3 altogether. Negative 2/3. So that's going to be negative 10 root 5 over 3 plus 5 halves. All right, so now I need to estimate this, right? I need to know how big it is. Well, this is certainly smaller than if I replace this root 5 with a number that I know and love, like root 4, right? So if I went ahead and replaced that with a root 4, right there. Let's see, this would be equal to negative 20 thirds plus 5 halves. So again, this would be like negative 40 sixths plus, and this would be, if I multiplied by 3 on top and bottom, 15 sixths. Okay, so that's going to be negative 25 sixths, so that's around 4 and change, so that's around negative 4. So it's whatever it is, it's smaller than negative 4. Let's go back here. So again, the answer in this case was 5 halves minus 10 root 5 over 3. And again, that this was smaller than negative 4. Okay, so our biggest value here, our absolute maximum, is definitely 9. So this is abs max. Our absolute minimum, now notice that we have kind of two contesters. We have this negative 7 halves, right? So that's pretty darn negative right here. That's around negative 3.5. And then we have this value right here, which we said is less than negative 4. So this value that's less than negative 4 is certainly going to win. So this is the absolute minimum, abs min. All right, so it took a little bit, but we can see that, again, 9 is the absolute maximum, and 5 halves minus 10 thirds times root 5 is the absolute minimum. All right, this was certainly a longer problem. You can see you really have to work for that full 18 points in this problem. Again, back from spring 2017. All right, I hope you guys enjoyed and took something out of this. I'll see you in chapter 15.